Okay, so I am using now the page from the textbook. And from the textbook, I'm using the data set of questions 1, 2, 3, and 4. So now you really are using the data set for questions 3 and 4, but it's in that guided practice where it says, do you know how? Okay. So now what we want to do is we're going to find both the mean absolute deviation and the interquartile range. And now I'm going to show you why we pick one or the other. Okay. So let's start with finding the interquartile range. Now, we got lucky because the book already put these in order from least to greatest, so we don't have to do that. That step's done. But now what we need to do is determine where is our median, and then first half of the median, second half of the median, and then we'll subtract them and find the IQR or the interquartile range. So let's see how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 numbers, which means we're going to pick the middle number. We don't have to add 2 numbers together and divide by 2. So the middle number is going to be 7. So here's my median. So now what we want to do is find the median of the first half of the numbers and the median of the second half of the numbers. Now we didn't get as lucky again with the fact that we have 2 sets of even numbers, but again, not too complicated. We add the 2 middle numbers together, divide by 2. Well, we know that 5 plus 5 is 10. 10 divided by 2 is 5. So quartile 1 is 5. Quartile 2 is going to be adding together 8 plus 10. Quartile 3, I'm sorry, is going to be 8 plus 10 divided by 2. 8 plus 10 is 18. 18 divided by 2 is 9. So quartile 3 is going to give me 9. So my interquartile range, again, is the difference between Q3 minus Q1, which is 9 minus 5 is 4. Okay? So there is my interquartile range. Now, what's the difference between interquartile range and the mean absolute deviation? Well, now what we want to do, and again, this is telling me what the difference between my 2 middle numbers in my first half of the data and second half of the data. So how far are they spread out? But now let's find the mean absolute deviation. Okay, so what I'm going to do is I'm going to keep this number, I'm going to write it up top, and I'm going to erase everything else. Okay, as soon as I find my eraser. There it is. Okay. So we're going to put interquartile range up here. It's 4. Okay, just so we don't forget what it is. Now I got to rewrite all those numbers, but that's okay. 4, 5, 5, 6, 7, 8, 8, 10. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay. So now we need to add them up and find our mean. So let's do this real quick. So 4 plus 5 is 9. 5 plus 6 is 11. 7 plus 8 is 15. 8 plus 10 is 18. And we'll bring down the 10. 9 plus 11 is 20. 15 plus 18 is 33. 10. 20 plus 33 plus 10, 53, 63. 63, 9 numbers, divided by 9. 63 divided by 9 is 7. So there's our mean, okay? So our mean of all of our numbers in our original data set is 7. So now what we want to do is we want to subtract 7 from each one of these numbers, okay? So now let's do that. Again, let me find my eraser. You all should be used to this, me trying to find something while I'm doing in class. It's usually the pen from the smartboard. So 4 minus 7, 5 minus 7, all the way down. I don't need to write them all out because that would just be silly. 4 minus 7 is 3. 5 minus 7 is 2. 2, 1, 0, 1, 1, 3, 3. Okay? All I did, again, I just subtracted each one of these numbers. I subtracted 7 from it. And again, I just made them all positive because I'm going to find the absolute value of each one, if you remember from, I don't know, 2 videos back. Okay? So now I need to add these up, and I want to find the average of the difference, or the mean deviation. How far did we deviate from the actual numbers? Okay? So now, 3 plus 2 is 5, plus 2 is 7, 8, 9, 10, and 6. 6 is 16. Let's do that again just to make sure. 3 plus 2 is 5, plus 3 is 8, plus 2 is 10, plus 6 is 16. And again, we're finding the mean of that deviation. So again, 16 divided by 9 is, again, I'm going to use my calculator. It's going to be 1 point something, but let's do it anyway. 16 divided by 9. 1.7 repeating. So we're going to take that to 1.78. So our mean absolute deviation is 1.78. So what do you notice? Well, the interquartile range is 4. The mean absolute deviation is 1.78. Which one is smaller? Which one is closer? Okay, which one is closer to 0? Which one is right in the middle? Well, the mean absolute deviation is the closest number. But here's where it gets tricky. What if I added an outlier? Okay, and you might be saying, what's an outlier? Okay, well, an outlier is a number that is way beyond what the rest of these numbers are. So if I added a number like 45 to that list, okay, and that'll happen. You'll get a list of numbers. Now, that 45 is going to throw everything off, okay? So now, we added up all of our original numbers, and we got 63, and then we divided by 9, and we got 7. Now, if we add 63 plus 45, I get 108. And now I divide that 108 by 9, or by 10. That mean goes up to almost 11. So you see what it did was it really messed up our mean, having this crazy big number in our list. So your question is, the question I want you guys to understand is this. When do I use interquartile range? And when do I use mean absolute deviation? Well, you can do that before you do anything. If you look at the list of numbers and you see numbers that are spread out and they're pretty evenly spread out, well, mean absolute deviation would probably be a good choice. If you have a bunch of numbers that are close together, like in this list right here, and then you have some crazy number at the end that makes that whole that mean of that list go way up, or on the opposite side, it would go way down. If all this was 40 and 50 and 50, and we had like 2 on the other end, it messes everything up. So if you see, again, what's called an outlier, a number that doesn't belong with the rest of the numbers, that's what an outlier is, then what you'd want to do is you'd want to use the interquartile range, okay? So interquartile range is when you have an outlier. Mean absolute deviation is when you have all your numbers are relatively in the same general area, okay? So again, these videos are helpful because unlike in class, you can rewind me or you can replay me, okay? So hopefully you guys are feeling good. I hope everybody is enjoying their time off, but also getting a lot of work done. And I do miss you guys, and I hopefully will see you at some point. Okay? Take care, everybody.